Hello students, in this video we will solve a question from CSIR NET December 2024. Here we are given an electron is in the spin state psi is equal to 1 by 5 3i4 in the SZ basis. A measurement of Sx is made on this state. The probabilities of getting h cut by 2 and minus h cut by 2 are. So to solve this question, the first thing that you have to remember is when a measurement is done on a system, the system collapses to one of its eigenstate. The system collapses to one of its eigenstate. Now the output of the measurement, this is equal to eigenvalue of the eigenstate. Eigenvalue of the eigenstate. The third important point is probability of transitioning from psi I to psi f, that is an initial state psi I to psi f. This probability, this is equal to modulus of psi f psi I squared. Now in this problem we are given the initial state psi I is equal to 1 by 5 3i4. Now to use this formula of transition probability, you have to make sure that the given state is normalized. So let's see if psi I is normalized or not. To check if a state is normalized or not, what we do is we take the inner product of it with itself. So if we take this, we will get, when we write bra psi I, we will write it as row vector. So 1 by 5 3, and we will replace I by minus I times 1 by 5 3i4. Therefore this is equal to 1 by 25 9 times minus I squared plus 16, which is equal to 25 by 25, which is equal to 1. Therefore the state given is normalized. Now let us find the final state. The final state psi f. Now in the question it is said that a measurement of Sx is made on this state. When a measurement is done, the system collapses to one of its eigenstates. Therefore the final state psi f will be eigenstates of Sx. Eigenstates of Sx in the SZ basis. Now you have to remember the eigenstates of Sx, Sy, Sz in the SZ basis, the basis in which Sz is diagonal. The eigenstates of Sx in the SZ basis are 1 by root 2, 1, 1. This is the eigenstate with eigenvalue plus h cut by 2. The other eigenstate is 1 by root 2, 1 minus 1. This is the eigenstate of Sx with eigenvalue minus h cut by 2. Now the probability of getting h cut by 2 and minus h cut by 2 are, if we are getting the output h cut by 2, then that means the final state is 1 by root 2, 1, 1. If we are getting the output as minus h cut by 2, then the final state is 1 by root 2, 1 minus 1. Because according to the second point, the output of the measurement is eigenvalue of the eigenstate. So if we are getting the output as h cut by 2, then that means it is in the eigenstate with eigenvalue h cut by 2, that is 1 by root 2, 1, 1. And if we are getting the output as minus h cut by 2, then it is in the eigenstate 1 by root 2, 1 minus 1. Therefore probability of getting the output as h cut by 2, this is equal to modulus of psi f psi I squared, which is equal to, so for output to be equal to h cut by 2, the psi f will be 1 by root 2 1 1 1 by root 2. When we write it as row vector, it is like this, and psi I is given here 1 by 5 3i 4, 1 by 5 3i 4. This is equal to, and you have to square it, take modulus squared. This is equal to 1 by 25 times 2, 3i plus 4 times 3 into minus I plus 4, which is equal to 1 by 50 times 9 minus I squared plus 16, which is equal to 25 by 50, which is 1 by 2. Therefore, probability of getting h cut by 2 is equal to 1 by 2. Now there are only two states and total probability is 1, so probability of getting minus h cut by 2 will be equal to 1 minus 1 by 2 is equal to 1 by 2. Or you can do it using the formula also, p of minus h cut by 2, this is equal to, in this case you will have the final state as 1 by root 2 1 minus 1, because you are getting the output minus h cut by 2. Therefore you will put it here, one by root 2 1 minus 1, 1 by 5 3i 4 modulus squared, which is equal to 1 by 50 times 25, again you will get 25, this will be equal to 1 by 2. Therefore the correct option here is 1 by 2 1 by 2. The probability of getting h cut by 2 is also 1 by 2, and probability of getting minus h cut by 2 is also 1 by 2.